Good afternoon, everyone. Good afternoon. Hope all is well. Hope everyone's doing all right. So as always, we'll give everybody a chance to get in and then we will get started. All right, so it looks like majority is in now. So we last class left off where we closed out 3.1. We're looking at 3.2 today. Probably just do 3. They're relatively short sections. But looking at math lab and math lab activity, I don't want to push it too far and get too far ahead. Trying to give you guys a chance to get in there and get your stuff caught up. So please take advantage of that. We'll talk a little more about that when we close out today. So 3.2 is picturing distributions of data. And so both of these sections are pretty much talking about graphs, different types of graphs, you know, making sure you can read them properly and good stuff like that. So we'll just walk through them, talk about them. I figured out a way, you know, like I told you before, I figured out a way to actually put these up instead of me trying to draw them. So we got that going for us. And so after today, we'll have one more section out of chapter 3, 3.4, talking about how graphs can be misconstrued and everything like that. And then that'll be it for chapter 3. So looking at the bar graph, it uses a set of bars to represent the frequency or relative frequency of each category. The higher the frequency, the taller or longer the bar is. All right. Give me a chance to vote.
Can you go back up? I'm sorry.
There you go.
Thank you.
No problem. Where's somebody else? All right, scrolling up some. About the bar graph. Anybody still using that?
I am.
All right.
I'm here.
Hey.
Oh, I'm sorry. I thought you said something.
Oh no.
Sorry, I didn't want to, be here, not,
Oh no, you're fine. I'm just letting people copy the notes right now.
Oh, sorry.
All right, can we scroll up? Very good. Everybody all right? So here we just have an example of a bar graph. See over here is the frequency. And the bar graph goes to how high accordingly. And so what they could easily ask you, what percentage of students score a C, that type of thing. They have questions that will be geared towards. So if you ever see questions that you don't understand, what they're asking of you, then make sure, feel free to ask. Notice how they say the bars do not touch when you're dealing with a bar graph. All right, anybody holding on to this before we go to the next graph? So you have a couple of labels that are important for graphs. You have your title, caption, and so the graph should have a title, to explain what it is. Let's see something. Okay, talk to me after class so we can see, make sure you're straight. All right, and then the vertical scale and title, making sure you're labeling what's going on over here, or there should be a label. Same thing with the horizontal scale and title, and then the legend, let you know if there's multiple sets of data, you'll see that, when we get to some other graphs, what each color or category represent, so everything should be labeled, when you're talking about these graphs. And let's say if you were creating one on your own, those are the guidelines. You want to make sure everything's labeled. So if somebody's reading it without you being there, then, they'd most definitely be covered, have an understanding of what's going on. Anybody holding on to this, copying this?
I'm still copying.
Okay, take your time. I just don't want to be sitting here and nobody's copying it. Yeah.
Is this all in the e-text?
Yep.
Oh, okay.
Oh, thanks. Appreciate it. Somebody said, talking about, appreciate that. Yep. All of the stuff, I'm pulling it straight out of the text. Yep. All right, so the next type is the dot plot. Is a variation on the bar graph in which we use dots rather than the bars to represent the frequency. So it's the same thing, but once again, using dots rather than the bars. So which one you decide, you of course, is your preference. All right, can I scroll up? Go too far, let me know. All right. And so here's an example of the dot plot. Very similar to the bar graph. You know, if you wanted it to be a bar graph, you could have converted. All right, we good to go? Scrolling up. Okay. So Pareto chart is a bar graph in which the bars are arranged in order from highest to lowest. So here's a regular bar graph, and this is a Pareto chart. Once again, it's the same information, same bars, it's just that it ranges from highest to lowest. Descending order. All right, can I scroll? Very good. All right, next one, pie chart. So it's a circle, in other words, a pie divided so that each wedge represents the relative frequency of a particular category. The wedge size is proportional to the relative frequency, and the entire pie represents the total relative frequency of 100%. So all of these need to add up to 100% if it's a pie chart done correctly. Everybody good with this one? All right. All right, next one, we're looking at histogram. It's a bar graph for quantitative data. The bars have a natural order and the bar widths have specific meaning. So here, when you look at this bar graph, you know, the width goes from 70 to 75, you know, then 75 to 80 and so on. So notice they are connected. Remember the bar graphs before weren't connected because it was quantitative, because of the way the quantitative data was set up. But here it matters because that's a range right here of 70 to 75. And then the range here from 75 to 80 and so on. So there were 4 people that scored from 70 to 75, 7 people that scored from 75 to 80. You know, that's how you'll read that. Then the line graph is the same thing, it's just done with a line and dots. All right. Are still copying? If so, it's fine.
Yeah, it's just 5 seconds.
Yeah, no problem. Take your time.
Thanks.
Mhm. All right. Are we okay? Anybody still copying? Anybody all right? All right. So now the next one, stem leaf plot. I know people have had questions about this before. I know my other class, I think it was 245, they actually had to do it. So I don't think you have to do it in this class, but we'll just walk through it, make sure we're okay with the process. So stem leaf plot. When we look at the leaf is going to be the rightmost digit of your data value. And your stem will be all of the values that precede that rightmost digit. So when I look at the number 53, the 3 will be the leaf and the stem would be the 5. Same thing with 127. The stem would be, not stem, but the leaf will be 7, the rightmost digit. And then the 12 will be the stem. So once again, the rightmost digit will be your leaf, and everything that precede that rightmost digit will be your stem. All right, can I scroll up? All right, so here we have a random data set. I listed them from least to greatest. Of course, your data set does not necessarily have to be from least to greatest. Greatest are listed from least to greatest. But that's how this one is set up. So we have 41, 50, 56, 71, 72, 72, 75, 80, 80, 82, 83, 84, 88, 88, 89, 91, 92, 93, 100, 101, 101, and then 112. And so you do want to make sure you find your smallest value and your largest value. And in this case for us is 41 and 112. And so that means that this data set goes from the 40s to the 110s. All right, so let's go ahead and do this. If I go too far, let me know. All right, so if you had to generate your own stimuli plot, first of all, we said we're going from the 40s to the 110s. So that's why this is set up this way. You know, the 4 represent 40, 5, 50, 6, 60, and you keep going to 110s. And then for each leaf that is represented, or each data value, let me say it like this, for each data value that's represented, there should be a leaf. And then you write that leaf that's attached to its stem. So if you have 41, then that 1 needs to go right here beside the 4. 50, that will be 0, and then you would do 56. Now, notice we don't have any values in the 60s, so what you should not do is put a 0 here because that represents the number 60. You would just leave it blank. And then from there, follow the same process. So that's 1, 72, 72. If you used to repeat it, you write it more, as many times that it is repeated. 75. Then we have 80, 80, 82, 83, 84, 88, 88, 89, 91, 92, 93, 100, 101, 101, and then 112. And so that would be a assembly plot. All right, problems, questions?
Yes, where would I apply the stimuli plot?
It's just another way to represent your data. It depends on what you want to represent and how you want to represent it.
Okay.
So let's say if you did research on your audience and there are a bunch of people who like numbers,
Yeah.
this may be more impressive to them than seeing a bar graph.
Okay, gotcha.
It's all about trying to appeal to your audience and really get them to get on your side. So you would do different things. But if you did research on your audience and they're a bunch, let's say those people are more artsy, and you know that's the type of people you're dealing with. Colors might be more appealing to them, and so you might do bar graphs. You might even do bar graphs with a little bit of graphics, and make your bars like that versus just straight. You know what I mean? It's just different ways you can appeal.
Yeah.
Yep.
Yeah, definitely. I got you. Thanks.
Can we go back up to the numbers real quick, just so that I just wanted to get the last line. Thank you.
No problem.
Thank you.
No problem, not a problem at all. Anything else, anybody else? I think this is the last one, yep, before we go into 3-3. Anything else? Questions, everybody good? So, like I said, they're just emphasizing the type of graph you could see and come across. And if you have any problems or issues with reading any of these graphs, always feel free to bring them up and we can talk about them more in depth. So 3-3, once again, just emphasizing more graphics or graphs, but just talking about graphics that you may see in media. And so here's not really not much notes, just really I just want to point it out and just show you what they're talking about. They didn't have much notes in that section either. So here's a multiple bar graph. So called multiple bar graphs because you see we have multiple bars, right? And so legends will always be key to making sure you have full understanding of what type of information is being given to you from these bar graphs. So the dark brown is going to be in reference to the men. And then I guess you say tan is going to be in reference to the women, and with certain degrees, and from there you can see once again you see all of this stuff is being labeled here, as information. So if you ever had to build these graphs out on your own, you always want to make sure you're labeling things properly, so that people who are reading it without you being around can actually read them and understand what's going on and what you're trying to say. Next one is a multiple line graph. Once again, you have a legend that will actually dictate and let you know what you're dealing with, what lines go to what colors go to what, and so on. All right. This is called a stat plot. It's called that because it's stacking information vertically on top of each other. All right. And this is similar to a line graph. You see how it's going up and down according to the years. So it's just, once again, just like your classmate mentioned, or discussion we talked about with your classmate when you're saying, why would you use one versus the other? And, it's all about appealing to your audience, And this is a geographical one. Probably see something like this more so when you're dealing with Weather Channel and stuff like that, when stuff is based on the region and everything like that. So geographical data can be displayed with color-coded map. And, just different things, just depends on what you're trying to portray. And then once again, you have your legend. And we're talking about gallons here, you're talking about gallons of oil, used by state. And so your range here, 4,000 to 499 is just for certain states. Just reading according to the color code. Let me make sure it wasn't anything else in 3-3. While I confirm this, any questions on anything? Anything that you've seen?
Yes, back up there where it's had the statistics for the not employment, but the college education, the men and women, the one up from there. Right there.
Mm-hmm.
Yeah, so I was looking at under, is that real statistics? See under here, 2014.
I'm not sure. I'm assuming because they put this right here that it is, but of course I can't confirm. All I know is what the book put in there. But yeah, I'm assuming that it is correct because they did. They gave you the source, U.S. Census from 2014. Did something pique your interest? Is there a reason why you asked?
Yeah, yeah. I was looking at the I was mentioning in the other class how my other professor was asking how things may have been affected. The job market, I was like, one thing, the education standard or requirement for jobs have risen, like jobs that require just associate's degree are now requiring bachelor's degrees, especially in the medical field. But then I was looking down at where you have some college and no degree is making right around not too much of a difference from an associate's degree. So it's like, are they weaning out the associate's degrees?
Well, I'm looking at this. Let me look before I make this statement. Let me go back.
Right, because I may not be getting the full grasp of information on this graph that I was kind of.
Give me 1 second. I'm trying to get back to it because the region may mean something, the fact that it might be
Okay.
all of the United States, because if you're talking about the average, then, certain states, then that means they're not including cost of living. So certain states going to be up here, you know what I mean?
Okay.
Where
Okay.
because of cost of living, but that has, you know what I'm saying? Like, let me see. Let me go back to it and see if
Okay. So would there be like macro versus microeconomics?
yeah,
I'm trying to connect something. Okay.
yeah, I
All
think that's
right.
where,
Got it.
they not getting
Okay.
as deep as you are.
Yeah.
To show you an example of a graph, but you're going too far in. You too in. You too
I
deep.
was trying to connect like that. I promise that's the only way I can learn. I have to connect it some kind of way, and then it's making everything make sense. So I connected this for a minute because I mentioned something in the class the other day, but I was like, wow, this is it. I just mentioned something about it. It seems like the associate's degree are, is not adding up to what it used to.
Right.
On the same jobs. Yeah.
Right. And then that goes back, well, that goes to, not goes back because we haven't gotten there yet. The next section, how it talks about how graphs can be misinterpreted or used in a certain way. See, one thing I always say about statistics is that they say numbers never lie, but they can mislead. And if you use these things in a certain way, you can sway people whatever way you want to sway them if you make adjustments in your graphs and stuff like that, which is what the next section is about. So let's see.
I was a little ahead of myself.
But no, it's a good statement to look at. This says college education income. Two clear measures first by looking at the bars across categories. Greater education. Yeah, see, I think this is just a broad sweeping statement just for the United States. But I think if you want to clearly make your statement, because I think your statement is actually more accurate than this graph, you would actually go state by state, maybe even region by region, because cost of living matters. You know what I mean?
Okay.
Wherein,
yes,
if I have an associate's here in Virginia, I'm not going to make the same amount I would make in New York. You know what I mean? But their cost of living is higher in New York, that type of thing.
That's right.
You know what I mean? So if you just bunch everything together from all states, it's not gonna be an accurate depiction. But if you're trying to sway people in a certain direction, you're actually using legitimate data, and your graphs are accurate portrayal for what you're trying to do. You see what I mean? And
I got you.
That's how states.
Okay.
Yeah, that's why when you look, especially with presidential candidates, political stuff and all that, they can take data for, let's say, Obama, let's say their party can say something, and then let's say the Trump party can use that same data and say the complete opposite, because you can take these data values and use them.
Manipulate, right? Okay.
Exactly. So
wow, just learned something.
Yeah. So you most definitely have you're on to something when I say it like that. I don't know if this class, because we just got a new book for this one, so I don't know if we're going to go there. We may not, but when we start dealing with outliers, they'll actually tell you in the book, you run your data with the outliers, you run your data without the outliers. So, and then whichever one supports your case the most, that's the one you use. So I mean, they tell you that, that's how you do it. So basically what happens here, if you present your data and somebody say, hey, I notice these figures right here, they're outliers, very extreme values. Well, you can say, well, yeah, they are outliers, but they are data values that I observed. So you can, but then let's say if you don't use them, but somebody noticed that you did not use them, and they say, hey, well, what about those values over there? Why didn't you use those? Oh, I didn't have to use those because those were outliers. They're not norm. They're not values that are normal. You see what I'm saying? Like, you can use them or not use them. And so that's how we can be manipulated if we're not careful. Yeah.
Definitely. Wow, got it. That's good. I needed to learn that.
Yep. So that's why it's fun. It's fun, but it's dangerous at the same time if you're not careful.
Yes, it is.
All right. Anything else? Anybody else? Because I didn't want to go too far. Like I said, we have one more section in chapter 3, which deals with, like I just mentioned to your classmate, how graphs can be misinterpreted, by using tick marks a certain way and all the stuff like that. So we can get into that next class. But I was looking at Math Lab, earlier today and looking at the activity. And we want to get a little more active. I'll say that. It's not everybody, but yeah, we do want to get a little more active in there. So
That's
don't
me.
want to push it. Say again.
That's me. That be me.
See, I wasn't gonna call out anybody, but we appreciate you being honest with us.
Yeah, that's why I'm up here asking questions and everything. So yeah, maybe the difference.
Yeah, not a problem, not a problem. So next class we'll do 3-4 and we'll do 4-1-4-1. It's like easy calculation, mean, mode, and median. That's the average, the values that are the most, middle value. So we'll get into that as well. But we can leave it right here, right now. That'll give you the weekend to hopefully get in there, get in the math lab, knock some things out, and get closer to what we're trying to do. Oh, also, this, and I know I owe you guys a take-home test. And see, nobody reminded me, nobody want to take it. That's all right though. But it's all good. I'll post it sometime shortly. But test 1 is going to be chapters 1 and 2. Test 2 is going to be chapters 3 and 4. And this one, I think we should go ahead and make that proctored since it's not going to be a heavy test. So that means if we do a test that has lighter calculation proctored, then that means for the next one, I most definitely let it be take home, and it doesn't have to be something that's heavy. It's trying to, sweating while I'm looking at you trying to take it. So just give me a heads up of what I'm planning on doing. We'll make that proctored. So that means, what will happen is then we'll talk about it when we get closer to closing out chapter 4, put a date out there, give you an opportunity to have a review date, ask questions, all the good stuff like that. So, but what you would do is you would just log into Zoom, make your camera enabled, show your ID, since I haven't seen everybody yet. And then from there, I'll give you the password, and then you would just take the test under the time of the class and stuff like that. So like I said, this is lighter calculation. You see that we're talking about graphs as well. So, we'll take a light test and let that be our first proctored test versus waiting until chapter 5 or 6 or 7 or something and, letting that first one be proctored, which it may be, heavier calculation from there. We got to at least get something in there that says we did something proctored, so let's go ahead and start there. So before we close out, questions, concerns, comments. I know I have one of you I have to talk to about math lab connection, but I'm talking about outside class stuff. Anybody have any class questions?
I have a question about the test.
Oh.
I'm sorry, go ahead.
I have a question about math lab after class.
Okay, not a problem. And somebody said they had a question about the test.
Yeah, I was wondering, I know you posted the recorded lectures this for last week. Is that going to be something you're going to normally do?
Oh yeah.
Or
Mhm.
okay, all right. Yeah,
Yep.
no, thank you.
Yeah, no problem. My goal is to do it either Thursday or Friday. I had a hectic weekend, so it messed me up. But my goal is to knock it out by Friday and shoot them to you so that you guys can have them to review if you decide to. Yep.
Okay, I have a question.
Yes.
I'm just being nosy. So the test on chapter 1 and 2, is it gonna be like the math lab like questions, or is it gonna be like problems? Like you have to solve them?
No, it'll be straight from math lab. What you did in your homework, I'm gonna populate problems from those homework questions and make them into a test.
Okay, got you. Thank you.
Yep.
When is the test for chapters? The first test. Like when
I'm
is
gonna
it?
I'm gonna post it, and then from there, it's up to you to knock it out as soon as possible.
Okay, is it gonna be on Math Lab or is it gonna be a link Math Lab?
Yeah, it'll be Math Lab. So everything I do is gonna be generated through Math Lab. Even this proctored one will be done through Math Lab. It's just that you would have to do it, while I'm watching you through Zoom. But everything will be done through Math Lab.
Okay, awesome. Thank you.
Yep, no problem.
Where do we find the test on Math Lab, or where will it like appear?
Hold on 1 second, I can show you. Okay, yeah. All right, so what's gonna happen here is you'll be able to click on your assignments. And right now it says show all. It'll show up under show all. But if you want to go straight to it, you can go test quizzes. And then it would be right here. Yep. But
Thank
nothing.
you. I wasn't sure about that.
Yep,
If it
yep.
appeared somewhere else.
Yep, no problem. Yep.
Is it time?
Oh, hold on. I got 2 questions.
You can go ahead.
I think I heard, was it timed?
Yeah, is
So
it time?
no, if I just post it for you to do on your own, it will not be timed. Now, the one we're doing during class, that will be timed because that will be during class time. But we will talk about other options like makeups and stuff like that too. But we'll talk about that when we get closer to actually doing the test. But that during the proctor time, it will be timed. But the one I sent to you guys that you can do on your own will not be timed. All right, I had another question on the floor.
So those sample quizzes and tests, do that go to like our actual grade on Math Lab?
No, I can't get rid of them. That's just something that Math Lab has up here. I wish I could,
Oh,
but yeah, there was no way for me to delete them. So,
okay, because I started doing them because I thought it was the actual like test.
oh, yeah, sorry about that. Yeah, it will be up, it'll be right above this stuff. But yeah.
Okay.
Anything else?
Will it hurt us to take those little pre-tests and review quizzes or anything, just to practice?
Nope, not at all. Not at all. Nope, won't even affect your grade at all. All right, anything else, anybody else before we close?
That's kind of my question. So those homework assignments and Math Lab, we don't have to do.
Okay, hold on. Now, these are sample tests and quizzes that they were talking about. Your homework is a different category. So those you have to do.
Okay.
Yeah, so these you have to do. That's part of your grade. But they were talking about those samples.
So we do got to do all the homework ones that's in Math Lab.
Yes.
Okay, so our homework is that and the definition.
Yes. Mhm.
Okay.
Got to do all them.
Yep, and you want to get at least excuse me, at least a 75 or better. Is the standard for your homework. All right, anything else, anybody else? All right. So if you guys are good, I'm good. I'm gonna stay back for a couple students that I had that need to talk about Math Lab. But I will see you guys next week. Have a great weekend.
You too.
Thank you. Thank you.
Thank you. Thank you.
Take care.
Thank you.
Thanks for saying. Take care. All right. So what do we got? Oh wait, hold on. Let me stop the recording.